the solutions to our Foundations 11 practice exam. A few notes here in addition to the actual date and time of the exam is that I'll be available for help on Friday, this Friday, from 12 to 3, and I'll likely be in 112, but if I'm not for some reason, you can email me and we'll set up some time. Also, this is wrong. It shouldn't say Monday, June 17th. It should say Monday, June 20th. That is the morning of the exam. I'll be setting up the grade 10s on their mock from about 8 to probably around 8:30, so I put a safe buffer so that from 9 to 11 I should be available to answer any questions. All right, you're going to be allowed to bring in one reference sheet that you create yourself. You can write whatever you want on there, provided there are no solved examples. And so we'll be checking at the beginning of the exam to make sure that that is true. And you'll be provided with a z-score table. So you don't need to write out all of the values of a z-score table, and also the sine law and cosine law. Great. Okay, and also I'd like you to bring a device because you'll be able to use Desmos during the exam. All right, so back to the beginning of the semester, we're going to start with statistics. So we're going to start with, we're given a grid showing the ages of 10 randomly sampled customers. All right, so we've got some ages here. Looks like there are 1, 2, 3, 4, 5, 6, 10 of them. All right, so we're going to start by finding the mean. So to find the mean, that means we've got to add all these numbers together and then divide it by the number of terms we have. So that means we're going to 25 plus 35 plus 40 plus 34 plus 17 plus 21 plus 23 plus 28 plus 46 plus 14, and you add those all up and you divide it by 10. Okay. So 23 plus 35, 40, 34 plus 17 plus 21 plus 23 plus 28 plus 46 plus 14 divided by 10. And so we get an average age of 28.1 years. 28.1 years. All right. To find the median, median means middle, and you can think of a traffic median here. So in order to find the middle age, I'm going to have to put these in order from least to greatest. So least is 17. Next least is 21. And 23. Another 23. Oh, actually 14 is least age. 14. And 28. 34, 35, 35, and 40, and lastly 46. I'm just going to check to make sure I didn't forget any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, great. So to find the median, we're going to look at the value that is right in between. So we're going to start at the far ends and cross those guys out. We're going to find the one that's right in the middle of all these ages. And we actually find this is an even number of terms. And so to find the median between these terms, I would actually add these two up and take the average of those ages to find one right in between. So that's 23 plus 28 divided by, equals divided by 2. So the median age equals 25.5 years. Now, that eventuality was actually a bit of a mistake. I actually intended to only have an odd number of terms for any of our questions. So you can expect on the exam, I'll make sure that we don't have to worry too much about that eventuality of medians. All right, moving on to mode. Mode means age that shows up the most, and it looks like there's really only one age that shows up more than once, and it was 23, so that's our mode. And our range is our largest value, take away our smallest. Largest take away smallest. So that means 46 take away 14, meaning our ages range from 14 to 46, and so the range will be 32. Great. Right. Moving on. This question says we've got an average height of adult females 65 inches, and there's a standard deviation of 3.5 inches. And the heights follow a normal distribution. So we're going to label the horizontal axis, that's horizontal like the horizon of the normal distribution curve, the bell curve, for adult female heights. So in the middle, that's going to be our average, so 65. Okay, and that means each of these represents one standard deviation from the mean. So that means this one's going to be 68.5, and that'll be, maybe I'll go in this direction. That means 65, oops, 65 plus 3.5, plus 3.5, 72. Plus 3.5 again is 75.5. All right. 65 take away 3.5, 61.5. And take away 3.5 again, 58. And again, 54.5. Okay, and we're going to use this to answer some questions on the next page here. All right, so question B. What percent of adult females are between 61.5 inches and 72 inches tall? So I would look back at my table, and I find 61.5 inches here and 72 inches there, and so I would say, okay, well, that looks like we've got 34% to 61.5 inches and 65 inches, another 34% here, plus 13.5 inches, so that's 34 plus 34 plus 13.5, and that gives us 81.5% of adult females between those heights. So that's 34% plus 34% plus 13.5%, and that all gives us 81.5% of adult females. All right. So Ms. Frank is 68 inches tall. So we're going to calculate the z-score for her height. All right. So looking back, I look and say 68 is not quite a full standard deviation away from the mean. It's part of the way. And so a z-score, just to remind us, is really a way of measuring how many standard deviations are you from the mean if you're not an integer or counting number away. 68.5 is one standard deviation away, and 72 is two standard deviations away. So 68 is probably less than one standard deviation away. But in order to find out the exact value, I'm going to have to use a formula. All right, so the formula for calculating a z-score is to say, okay, the z-score is going to be the mean take away, our value take away the mean divided by the standard deviation. So that's our value of interest here, x. So that's going to be x. So just to be clear, x in this case is 68, and our mean is 65, and our standard deviation is 3.5. Okay, so when we calculate our z-score here, we're going to say, okay, well, that means we're going to have 68 take away 65 over 3.5, and that's going to give us 3 divided by 3.5, and what do you know? That's going to be a value smaller than 1. 3 divided by 3.5, oops, 3 divided by 3.5, 0.587. 857. Okay, so z-score of 0.857 means Ms. Frank's height of 68 is about 0.85 standard deviations from the mean. So it's not quite one standard deviation from the mean, it's somewhere a little bit less. Okay. So then the question becomes, well, what percentage of adult females are taller than Ms. Frank? So we may use a Z-score table for this. Okay, so just to be clear here, really the question becomes, well, okay, how many are less than 68 inches in this? Oh, wait, no. How many are taller? Actually, how many are greater than 68 inches? Okay. So if I look at my standard distribution, I would say that, well, intuitively, I would expect about 13.5% plus 2.5 is 16, I think. Yeah, 16 plus 0.15%. Okay, 16.15 plus a little bit more. So I'm expecting a number probably something like 17 or 18% are in this region here. So the way we find out the exact value is turn to our Z-score table, reminding ourselves that Ms. Frank's Z-score is 0.875. Pardon me, 0.587. All right, so we're going to look for 0.587. We're going to turn to the positive end of the standard distribution. Okay, and we're going to say, okay, we've got Z is 0.8. Okay, 0.85. Actually, 0.587, if we were to round it to 2 decimals, would be 0.56. Or, pardon me, 0.86. So actually, it's probably a little bit closer to 0.86 than it is 0.85. So we'll use this value here. And so that tells us that about, 0.8051 is the percent. So, however, if we look at the diagram here, that tells us the percent that are less than our region of interest, our value of interest. So our Z-score table says that this region, that is 0.8051, which in percent, we just move that decimal over twice or multiply by 100, we get 80.51%. However, we actually wanted this region here. So, to seal the deal, to find the value of the percentage of females that are taller than Miss Frank, we're actually going to take that away from 100%, which is everybody. So 100% take away 80.51%. That's going to be equal to 19.49%. All right. So we move on. We say Mr. Roberts' partner is taller than 15.39% of adult females. The question is, how tall is she? Okay, so this is really going through the steps in C and D backwards. We're beginning at a percent. We're going to go find a Z-score that corresponds to it, and then we're going to use the Z-score formula to work backwards and solve for a height. Okay, so first things first. We're going to look at 15.49%, and we're going to look for that on the Z-score table. Now, to remind you that first we're going to turn it into a decimal, so 0.1549. We're going to look for that. And it looks like we're on the negative side, so we're actually going to be looking on the taller end of the mean. And what was our value? 1.1549. 1.1549. Oh, actually we're over here after all. 0.1549. I feel like it's right in front of me somewhere, and okay. 1539. Oops. 39. Something seemed fishy, and there it is. 0.1539, which means that value, that percent, corresponds to a Z-score negative 1.0 0.02. Negative 1.02. So that's part 1. So now I go back to my z-score formula, which is going to solve for, in this case, we're going to solve for our height. We're going to solve for a value of interest. So we're going to plug that in. So we've got a z of negative 1.02. We've got a mean, which is still 65 inches, if my memory serves, and a standard deviation of 3.5 inches. Okay. So we'll plug those in, and we say negative 1.02 is equal to x, we don't know that, minus 65, and that's all divided by 3.5 inches. We're going to solve for x. Okay, so we're going to multiply both sides by 3.5. Okay, so we're going to get negative 1.02 times 3.5, negative 3.57. So it becomes negative 3.57 on the left. And on the right, these two operations cancel out. They're the opposite. So that gives us x minus 65. To isolate x, we're going to add 65. Do the opposite, add 65. And that tells us that actually Mr. Roberts' partner is 61.43 inches. Okay. All right, lastly, what percent of adult females are between 60 inches and 66 inches? Okay, now my first instinct is to look back at my normal distribution curve and take a look. Are 60 or 66 precise values shown to be some number of standard deviations, like 1 standard deviation away or 2? And if I look, I'd say, okay, well, 60 is probably somewhere about halfway in between. And 66 is a little bit bigger than the mean. Okay, so that region in there is what I'm going to be looking for, which means it's going to be maybe something like 34 plus maybe a little bit more than half of 13, so plus 8, say. So that's around 42. Plus a little bit more here, just one extra, I don't know, maybe that's another 10. 34, 42, so maybe around 50%, something like that, maybe even high as 60. All right, so we're going to take a look now. All right, now to do this, we're going to start by finding the number of females that are shorter than 60, and then the number of females that are shorter than 66, and then we're going to just subtract the women shorter than 60 inches from the women who are 66 inches and shorter. Okay, let's start with 66 inches. So, woman, I'm going to label this less than 66 inches tall. Okay, and I'm going to draw a little diagram for that because I think that really helps me visualize what I'm talking about. So I know this is 65, this is 66, and I want all those women in here. All right, now to find that, I got to start by finding out what the z-score is for 66. So z-score is, 66. Take away my average, 65. I'll divide that by the standard deviation of 3.5, which gives me 1 over 3.5. 1 divided by 3.5. So it gives me a z-score of 0.29. I'm going to round that to 0.29. All right. So if I want to know what percent of women correspond to that, it's going to be a little bit more than 50, probably a little bit more like 60, 65. All right, so I'd look and find 0.29. Okay, so I find the percent here is 61.41%, 61.41%, or, well, to take the decimal, we multiply by 100 to turn it into percent. So this corresponds to 61.4% of women. Okay, great. That's awesome. Now I'm going to subtract from that women less than 60 inches tall. Okay, so that, again, I like to draw a little diagram. So we're talking about, these are 65 in here, and we're talking about women that are shorter than 60 inches, so that's going to be somewhere around here. And we want this tail region here. Sometimes it's called a tail. Okay. So same thing. Z is 60, take away 65 this time, over 3.5, which is negative 5 over 3.5. Oh, oops. I could probably write that a little bit more clearly. Negative 5 over 3.5. Negative 5 divided by 3.5. That gives me a value of negative 1.43. Okay, so if I look on my z-score table, my negative values, negative 1.4 and negative 1.43, and I get this decimal here, which is 7.64%. And that corresponds to 7.64%. All right, of women. So if I want the number of women between, maybe I'll separate this into a last little section here. So to find the women in between, I'll just throw the mean in there as well. Oops, 65, that's 66, and that's 60. So actually I want the women here in this region. So to do that, I'm going to take away the percent of, from the percent of women that are shorter than 66 inches. I'm going to take away that tail end here. I'm going to subtract away that tail. So it's going to say, I'm going to get 61.41%, take away 7.64%. That's going to give me 61.41, take away 7.64, and I get 53.77%. Okay. Okay, I noticed a slight cut and paste error here. I didn't mean to go over the page with this. Okay, so, all right, first things first. So let's take a look here. A new car is designed to be driven for 100,000 kilometers. Oh, pardon me, a new car tire. Plus or minus 3%, 95% of the time. Okay. So really this is just some vocabulary here. So margin of error asks the question, how close are we with this? What are we expecting our values to be between? And our margin of error is, we would say, is plus or minus 3%, meaning really this new car tire should be last for this long, up to this long minus 3% or plus 3%, and that's probably the shelf life of that car tire. Okay, so the confidence interval, however, is really going to ask, well, what does that mean in kilometers? What does that mean for me? Do the math for me, basically, rather than say, well, okay, plus or minus 3%. What is 3% of 10,000? Okay, so to find the confidence interval, I'm going to say, okay, first I'm going to find out what is 3% of 100,000. So to do that, I'm going to turn 3% into a decimal, because in order to do math with percents, we got to turn it into a decimal. So it becomes 0.03. Now, to clarify how I did that, I said I'd divide my percent by 100. Okay. Of 100,000. So to determine that, I actually multiplied them together. 0.03 times 100,000 times 100,000. All right, I get 3,000. So really, this means 100,000 kilometers plus or minus 3,000 kilometers. But really what I want for my interval is to say, okay, well, these are likely going to be in between 100,000 take away 3,000, which should be 97,000 kilometers, to 100,000 plus 3,000 kilometers, or 100,000, pardon me, 103,000 kilometers. Like so. All right. And there is one more question that, just due to formatting error, ended up over here. All right, and the confidence level. So the confidence level really refers to how likely we are for that to be true, and this is 95% of the time. What that means is that 95% of tires should last somewhere between 97 and 103,000 kilometers in distance before they need to be retired. All right. So we'll do one more tonight, which is we'll take care of the angles and trigonometry section. All right. So we're going to start with just determining the measure of all the angles in the diagram. Okay. Now there's a lot of ways we can go about this. Maybe your method is different than mine. I'm going to try and go in order from A to G, and I'm going to see if that works. All right. So, well, actually, I can see a whole bunch of things I could do just with 50 degrees, which is this guy here. To start, I could say that A has a value of, well, I know that these two are angles on a line, and they must add up to 180 degrees. So I know that 50 plus 130 degrees is 180, and I get that by saying 180 take away 50 degrees is 130. And now the question doesn't actually ask us for this, but I'm going to indicate that I know this because they are supplementary angles. All right. I could argue that angle B, well, angle B I can see is what we used to call the X rule. You know, they're on opposite sides of two intersecting lines. So angle B has the same value as 50 degrees. And the X rule is actually called vertically opposite. That's the official name for that rule. Now, I could argue that angle C is 130 degrees. Now, I know that either because I could say it's vertically opposite to A. So if A is 130, C is 130. I could say that. And, you know, it's good standards and practices to write in our values as we go. I could also say that C is supplementary to 50 degrees, angles on a line. Or I could say angle C is supplementary to angle B, angles on a line. Either way is 130 degrees. I think I'm going to define it as being supplementary to 50 degrees. Okay, and this symbol here means angles in case we're unsure. Great, moving on, angle D. Okay, looks like I can use a similar argument for finding angle D, because angle D and 112 together, well, they make up a straight line. They're angles on a line. These are also supplementary, but now I want to go to my calculator and make sure I don't subtract 112 incorrectly in my head, because I know I'm prone to add an extra 10 or take away an extra 10 by accident sometimes. And so that tells me it's 68%. And again, those are supplementary angles. Okay. What's next? Angle E. So again, I can see several reasons to argue for angle E. The first one I see popping out at me is this looks like what we call the Z rule. They're alternate interior angles of two parallel lines. 50 degrees, and E are alternate interior. Now, I could make an argument actually that instead, that's 130 degrees and that's 68 degrees. I could argue instead that E and 130, well, they form this C rule, which says they have to add up to 180 as well to make that 50. Or I could say that angle E and angle B make up an F rule and are corresponding angles. All right, moving on to angle F. So I'll write that in, it's 50 degrees. Angle F has a value, well, I noticed that angle F is in a triangle with angle D and our original 50 degrees. Now I know that angles in a triangle have to add up to 180 degrees. So if I say I take 180 and I take away 50 and I take away 68, that's going to leave me with the 62 degrees of angle F. So that's 62 degrees, and I would say angle sum of a triangle. Nice and concise. All right, and lastly we got angle G. Angle G, well, I again have multiple options here, but I see a nice Z rule popping out at me. So I know that angle D and angle G are alternate interior angles, meaning they must have the same measure. So if angle D is 68, angle G must also be 68 degrees, and they're alternate interior angles. Okay. So we'll finish off the trigonometry section on this video, and for the next video, I'll move on to rates and, lines. Okay. Find the measure x in the following diagrams. All right, so here we're looking for this side length here. Now, maybe we should start by labeling up a triangle. A, B. So C is always either the angle we know or the angle we need, and then we'll make this B. All right. So what do we need? We need probably some sort of formula. Oh, right. And this is the lowercase a. That'll be lowercase b. That'll be lowercase c. All right. So question, what do we do here? We've got a few different rules. First of all, is it a right angle triangle? And the answer is no, or at least we don't think so. Okay. Do we know an angle and its opposite side? Or could we easily find an angle and its opposite side? And the answer looks like it's no. So that means we can't use the sine law, which means I think we've got to use the cosine law here. Now, the cosine law will be given on your formula sheet. So it looks like this, a squared plus b squared, take away 2ab times the cosine of capital C. Okay, so that means x is going to be my lowercase c, I'm going to square it. A is going to be 15.6 squared. B is going to be 10.5 squared. Take away 2 times 15.6 times 10.5 times cosine of 54 degrees. Oops, 54 degrees. All right, so I'm going to do this in a few steps. You may elect to do it all in one step, that's up to you. 15.6 squared, oops, 6 squared is 243.36. So x squared is 243.36 plus 10.5 squared, 110.25. Take away, I'm going to put all those together at once. That's 2 times 15.6 times 10.5 times cosine 54. And I get minus 192 point, I'll round that to 2 decimals, 0.56. Okay, or 243.36 plus 110.25, take away 192.56. So it tells me that the square of x is 161.05. Now, We weren't asked for the square of x's, we want to know what x is. So to do that, to isolate x fully, we're going to square root both sides. We get x is equal to the square root of our answer, which is 12 point, I'm going to just round that to 12.7 centimeters. Units originally were in centimeters. All right. So we're going to go through the same process over here for question B. So we're going to start by labeling up our triangle. So this should be angle capital C, and that'll be angle A, and that'll be angle B. Oh, I labeled it A again. It's been a long day. That means this is lowercase a, that's lowercase c, that's lowercase b. Fantastic. So do I know an angle and its opposite side? Well, I don't know any angles, so that's for sure not true. So I can't use sine law, which means I'm going to have to use cosine law again. Okay, so let's find out what goes on here. So lowercase c, in this case, is going to be 12. So maybe I'll write out the whole formula here. C squared equals a squared plus b squared. Take away 2ab cosine capital C. All right, and so we get 12 squared is equal to 16 squared plus 15 squared. Take away 2 times 16 times 15 times the cosine of our variable x. Okay. So this is going to be a little bit more of a sophisticated set of algebra steps in order to find our variable x. We've got to do a lot of isolating. But I think first thing we should do is simplify. 12 squared, I happen to know that one, is 144. I happen to know all these actually. 16 squared is 256. And 15 squared is 225. However, I don't really know this one. 2 times 16 times 15. So I can say that's 2 times 15, which is 30. All right, 16 times 30. Well, I know 16 times 3 is 48. So 16 times 30 is 48 plus a 0 times the cosine of x. Now you can verify that with a calculator if you like. I'm pretty confident in my answers for those. But of course, if I'm wrong, you get a cookie. Okay, we got to isolate x. So we're going to start by getting rid of everything that isn't x on this side. We're going to start with the thing furthest away. Actually, you know what? Even before that, we should simplify even further. We can add those two together. So it's 144 is equal to 256 plus 225. It's 481. Take away 480 cosine x. Now, to remind you guys, these are not like terms. We can't group these together. This does not become 1 cosine x, because this guy is being multiplied by a variable. For the same reason, we can't add 1 plus 2x. They don't group together. They're not like. They don't count the same number of things. So, okay, we got to isolate x. We're going to start with the thing furthest away, which is this 481. So we're going to take away that 481 from both sides of the equation. And I get negative 337. That's equal to negative 480 times the cosine of x. All right, now I'm going to isolate. Well, I still got to get rid of this negative 480. Is being multiplied by cosine x, so I'm going to divide by negative 480. 480. I'm going to divide this by 480, the negative version. So I forgot to put that in, so I'll just make my answer negative or positive. Okay, so I'm going to change that to a positive, so it should be 0.702. I think 3 decimals is good when we're dealing with trigonometry. Cosine x. Now that's pretty good. I still haven't isolated x. I still have this cosine. So I'm going to do the opposite of cosining to both sides, which is cosine negative 1. We're going to do that to both sides. Equals cosine negative 1.702. All right. So I put that in my calculator. First I should turn this to negative, sometimes negative 1. Okay, and then I'm just going to do the inverse cosine of my answer. I get 45.4 degrees. X is 45.4 0.4 degrees. Okay, so you're not going to do any algebra more sophisticated than that in Foundations 11, that's for sure. All right. So again, same formatting errors before, just seem to carry through. So the next thing is we're going to determine the height of the building. Now the building is over here on the other side. So we're going to determine the height of this building here. What is the height, x? All right. So there's a lot happening here. So I might start by just doing, well, really, anything I can. I don't really know what my first step is, but I do know that I can use some of my angle rules to say, well, these have to add up to 180 degrees, so I can figure out what this angle must be. So it must be 180, take away 48 degrees, and that leaves me with 132 degrees here. Great, and I also know this is in a triangle, so I can also find this angle in here. It's going to be 132. So 180, take away 35 degrees, take away 132, and it leaves us with 13 degrees up here in this corner. I don't really have a game plan right now. I'm just filling in things that I can figure out. Now, if I make this a full diagram here, I'm really looking for this height here. Okay, so it looks like maybe we have enough to get started here. All right. Now, the rule of thumb is if you have a question with two triangles, try and find what they share. And it looks like they share this side here. Okay. So maybe I'll start with a triangle that has a bunch of information. And I'll see if I can find that value here, which looks like the hypotenuse of that right triangle. So I'm going to label that H. Hype. I'm going to label it hype so I don't get confused with the height and think I'm done when I found it. All right, so to make this easier for me, I'm going to redraw that triangle out here. So I don't get confused, because I get easily confused. And so I know that I need to sometimes redraw things in a simpler form. It's so simple I'm not even going to write that it's 150 feet. That's 35, 132, and 13. And this is my height. Okay, cool. So I'm going to label each of these sides and angles. So it'll be, say, angle A, B, C. That means this is lowercase c. That's lowercase a. That's lowercase b. And really, we're looking for lowercase a. All right. So, question. Do I know an angle and its opposite side? And the answer is yeah, I do actually. I know that this angle C is 13 degrees, and the opposite side is 150 feet. So that means I can use a sine law, which again, it will be given to us. But I'm going to write it out here. Sine A over lowercase a is equal to sine B over lowercase b, which is equal to sine C over lowercase c. All right. So I'm just going to start plugging in things and see what it looks like. It looks like we got sine of A is 35 degrees over A lowercase a is just, that's our height. That's what we're looking for. Okay, and that's all equal to sine 132 degrees over B. And that's all equal to sine 13 degrees over 150. Okay, great. So this one has my unknown, the one I really want to find. This one has both of my values, so I can actually ignore this one for now. Now, I also noticed my unknown is on the bottom of a fraction. And I know there's this trick where I also have this other version of the formula, which says A over sine A is equal to B over sine B, which is equal to C over sine C. So because I'm looking for a lowercase value, I really should have started with this formula, but I can always just flip this upside down, which I'm going to do. Height over sine 35 degrees is equal to 150 over sine 13 degrees. To find this value, I'm going to multiply both sides by sine 35 because my hypotenuse is being divided by sine 35. Multiply by sine 35, and those cancel out. I end up with just finding my hypotenuse is equal to that whole business here. So that's 150 times sine 35 divided by sine 13. So that value becomes 382 point, I guess I'm round that to 2 decimal places, or 3 maybe, 4, 6, 7, and that's feet. Now, if I look at my diagram, original diagram, I'd say maybe that is maybe believable. If this is to scale and that's 150, maybe that's a little bit longer than twice as far. Okay, cool. So that's 382.467 feet. Great. Well, now I just have a simple right angle triangle problem. Okay. So if this is my hypotenuse of my angle, this is my adjacent side to my angle, that's my opposite side to my angle. I have to decide which trig ratio I can use that will find my opposite side, which is, I'm going to go with SOHCAHTOA. And that tells me that I'm going to need sine in order to find the opposite and compare it with my hypotenuse. Now, you can use a sine law for this as well if you like. I know a few of you prefer to use a sine law for as many things as possible. Power to you. I'm going to do it in a way that I think is simpler, which is to say sine of my angle, 48 degrees. That's equal to x, my opposite, or my height, divided by my hypotenuse of 382.467. To isolate x, I'm going to multiply 382.467 on both sides. Okay. Multiplied by 382.467 times sine 48. Okay, and it tells me my height, x, is 284 point... I think it's okay to round to 1 decimal place at this stage. That's a number of feet. That sounds like the height of a building to me. That's in the right realm. Maybe not for a 4-story building, of course. Okay. So I think we'll call it there, and in another video we'll find the solutions to the other values.